This tutorial for beginners will teach you how to use blueprint visual scripting in Unreal Engine 5 to implement game logic. Getting started with Unreal Engine can be quite intimidating, but I specifically designed this video so that anybody can easily follow along even if they've never used any game engine or never did any programming before. You'll create your first blueprint from scratch to make a pickup. You'll learn how different blueprint actors can communicate with one another, how to program things like a pickup spawner, an elevator using timelines, a flying enemy that chases the player, and much more. By the end of this, you'll have a fundamental understanding of blueprints and a simple but complete game with a win and lose condition, which you can show off to your friends. So first of all, just quickly, what are blueprints? Blueprint Visual Scripting is Unreal Engine's node-based system that allows you to implement game logic and systems without having to write C++ or any other type of code. Instead, we have access to a huge library of pre-made nodes which we connect together to program our game logic. Nowadays, some other game engines also feature visual scripting systems. However, Unreal Engine has been doing this for a long time, and that allowed them to create what is arguably the most robust and feature-rich visual scripting system. And while there can be benefits to also using C++ in parts of your project, you can make entire commercial games only using blueprints, and it should be the first thing you learn when getting into Unreal for game development. And yeah, with the State of Unreal livestream last week announcing that blueprints will be deprecated at some point during Unreal Engine 6's lifecycle, this is probably not the best time to post this tutorial, but with all the pushback they're getting, I'm pretty hopeful they'll change their mind, and I guess I'm also posting this now as an act of defiance to show them we're not giving up that easily. On top of that, even if they go through with slowly phasing out blueprints, we still have about 4 to 5 years left with our current workflow, and you should still learn blueprints since they're your gateway into understanding Unreal and object-oriented programming, and that will put you in the best position to then learn C++ or Verse later on. To follow along with this exercise, make sure that you have the Epic Games Launcher installed, and then also that you have one of the latest versions of Unreal Engine. I'll use Unreal Engine 5.8 for this, which just released recently, but you can also follow along with newer versions, and most things should still look the same for the next couple of years. So launch whichever version you want to use. Then in this project launcher, click on New Project, make sure Games is selected, and we want to use third person as the starting point. Down here, make sure it is set to Blueprints, Desktop, Maximum, and No Variant. Then just set the name. I'll call it Blueprint Intro, and click on Create. Now, if this is your first time opening Unreal Engine, the shader compilation might take a while, but it'll be faster the next time you open up the editor. But after a while, you should see this screen here with the third-person template stage loaded up. If we press play, then click into the viewport, we get control of the game, we can run around with WASD, we can jump with space, and we can move the camera. And this is actually using a blueprint. Just to quickly show you, in the content drawer, we have the third-person blueprints, and this BP third-person character controls basically everything we do here in the game with this character. We're gonna open it up and look into how this works later, but for now we want to start with a much simpler blueprint first. So let's make our first blueprint from scratch. And by the way, you can open and close the content drawer either by clicking here or by using Control and space. Okay, let's now make our first blueprint. Go to Content, right-click. I want to make a folder, so New Folder, and just call it Blueprints. Then double-click to open it up, and now right-click again. And here you can see we have some options of objects that we can create, but we want to create a blueprint class. When creating a blueprint, we have to pick a parent class. And if you're completely new to programming, specifically object-oriented programming, the terminology of parent and child class might already confuse you, but it's actually not that complicated. And without getting too deep into it, this terminology comes from a concept called inheritance, which is part of object-oriented programming. And it allows a parent class to pass down its properties to its child classes. And just to give you an advanced example, in my JRPG Masterclass, we have the Battlechar base class, which is the parent. Then we have the Battlechar party base. We split into this child, and we can also split into a different child, Battlechar enemy base. And then from this, we have multiple children again, which are the different enemies, the different heroes, the different characters. And basically, we can pass down the sprite and material settings, the particle and damage number locations, pointer target. So everything they share is up here. And we can also have different functions and methods based on the class. And then here we just change like the health values, we change the attacks they can have, and things like that. So instead of having to copy paste and do everything from scratch, we just share what is the same, and then we just add what is different down here for the children. So basically in here, we just want to pick whatever is closest to what we want to create. So we don't want a pawn, we don't want a character, we don't want a game mode. We just want to make a simple pickup for now, which is pretty much one of the easiest blueprints we can make. And well, an actor is an object that can be placed or spawned in the world. So we want to pick the actor as the parent class. And it is customary to name these BP underscore as a prefix for blueprint. And then I'm just going to call it pickup and hit enter. And why do we do this? Well, it just makes it very clear what this is. And also if we hit Control and P, we can search in our project and it makes it very easy to just look for BP and things like that. Let's now open up the blueprint editor. So double click the BP pickup. And I'm just going to drag the window here. Okay, and this is the blueprint editor and it consists of multiple parts. Here in the middle, we have the viewport, right? So it shows us the visual elements of our blueprint. Right now, we don't have anything here except for this icon. That is fine for now. On the right side, we see the details panel. And here we can override all of the parameters that come from the parent actor class. And we can also add our own here to then change. On the left side, we have the blueprint overview. And here we have the event graph. If I click it, you can see this is where we can do blueprint visual scripting, which we're going to get into. We also have the construction script, which you don't really use a lot. And here we can then add our new functions, which we're also going to get into later, macros, and we can create our variables, right? So this is where basically all of the logic we use for our blueprints exists, and we can then reuse these parts here. But what we now want to focus on are the components here. So let me go back to the viewport, and here we can attach components to the blueprint like audio, a skeletal mesh, a cube, a sphere, a plane. Many different things exist here that we can add to our blueprint. And the first thing we want to do is, well, because we want the player to see the pickup, I just want to use a sphere here, right? And you can see the sphere now pops up here. We can rename it, but I think sphere is fine. I'll just click away. And now let's just place this in the actual game world. So let's just compile and save and go back to the stage. And I want to place this in front of the character. You can see here, this is the arrow where our character looks into this direction. And I can go to the content drawer. We have the BP pickup. I just want to drag it out here and drag it up in the air a little bit on these arrows. And just on a side note, to move around here, I can just right click, hold it, and then use WASD to move around like a first person shooter. If I start the game now, the ball, it just floats in the air and it blocks our player, right? But it exists, it is working. Now we just want to kind of change the properties little by little. First, I want to make the sphere smaller and also apply gravity to it so it doesn't just float in the air. So go to the BP pickup. On the sphere, here in the details panel, if I have it selected, we can see the scale of the sphere. And I can change this to, let's say, 0.5. But now I only changed it on the X, right? I want to change it on all of them. And I can just type it in one by one, right? 0.5, 0.5. But I can also apply this lock here. And now if I change to 1, all of the dimensions change at once. But no, let's just go back to 0.5 without having to do it one by one. And in this case, it's also important that mobility is set to movable, otherwise it cannot move. And now still while the sphere is selected, I can just look for simulate, and it should show this simulate physics. And I want this to be true, so I just check it and back out of the search. Of course, you can just scroll and find it, but the search bar here is very nice. Now just compile and save. Let's go back to the world, and you can see the sphere is now smaller. If I start the game, it is falling down, it is affected by gravity, and I can kick it around. So basically, we could make a simple soccer game already just using this. But next, we want to add some actual logic to our BP pickup, right? So this is where we get into blueprint visual scripting. And just to clear up some confusion, right, this is a blueprint actor or a blueprint class. And what we do inside here in the event graph, for example, this is blueprint visual scripting. And what we do inside of functions as well, this is blueprint visual scripting, which allows us to create game logic without having to use C++. We just use a node-based interface. So yeah, also open up the event graph to follow along, and just to show you how we can navigate here, I can right click and hold it and move around to pan around. I can left click just on simple nodes, or I can left click and hold and drag to select multiple nodes. I can then drag them around and do things like this. It feels quite natural. With the mouse wheel, you can scroll in and out as well. And that is basically how we navigate here. If you right click, we get this context menu, and here we have thousands of nodes. And yeah, you don't have to memorize them, you don't have to know them. Even me using Unreal Engine for like 8 years or so, I don't think I've even used 10 or 20% of these. And you will just use the same ones over and over again, the same couple of hundred nodes. And the 3 inactive nodes that we have here are actually quite important. And I will get into these later. Begin, play, tick. These are very important. The actor begin overlap, I actually don't recommend using it because it is very ambiguous. We're going to use a different node instead that makes it clearer what are we actually overlapping with. So for now, I just want to delete it. I can select it and hit delete on the keyboard. And just on a side note, I can also bring it back. Control Z, like any program, you can just undo a step. Control Y, you can then redo it. And this you will also often use if you make a mistake to just go back and forth. And yeah, let me just drag this up here. And now we just have the begin play and the tick. That is fine. And what we want to do now is, well, we want to detect if the player walks into the pickup. So it is an overlap event that we're looking for. And then we want the pickup to disappear. And for this, we have to implement this blueprint visual scripting logic. Now, Unreal Engine already gives us some events here on the sphere, right? I can right click it and you can see add event here, and we have add on component hit and a couple of different ones. And the one that we're looking for is add on component begin overlap. And I can click this and then we get this nice node. And you can also see this gives us more information than the actor overlap node that we had before. So that's just why I explicitly prefer to use this one. And on a side note, you can also just scroll down here. You see the same events that we got when right-clicking this and looking for add event. And the first thing you often want to do, kind of as a sanity check, you want to print string and see what happens if something is even happening. And I can just right-click here and look for print string, or I can also just drag off from here, let go, and then also the context menu shows up, and I can do print string. And usually this is the better method because it is context sensitive, so it only shows things that you can actually do if you drag off from a certain node input or output. And here are the development print string here. And what do I want to print? Well, I want to print the name of whoever overlapped with this pickup. So other actor, drag it in here, and well, ideally this should show us the name of the player. So let's just go in here, and I try to overlap, but nothing happens, right? Because, well, we're not really overlapping. The sphere is blocking us and we are kicking it around. So to do this, we want to change the collision settings to not block the player, but to overlap with the player instead. So let's click on the sphere and I can scroll down to the collision settings. Here we have collision, and collision presets is what we are looking for. Now this is quite complicated. I'm not going to get too deep into this, but basically what we want to do is we want to change it for pawn to not be blocking, but to be overlapping. And if you're advanced, you can create your own collision presets in the project settings and reuse them. But for now, we're just going to click on custom. And the only thing we're going to change is the pawn from block to overlap. And I actually also want to change the camera to ignore because we don't want the camera to zoom in if a ball is blocking us. And now let me compile and save this, go back to the map, and I walk into the sphere, and it is not blocking us anymore. It is actually printing the third person character 0, which is the first instance of our player character. And this brings us one step closer to achieving what we want, the player overlapping and then disappearing the pickup. So let's go back to the blueprint, and after the print string, well, how do we destroy this pickup? Well, there is a nice node we can use. It's just called destroy actor. And I can just have it here after we print, then we just destroy ourselves. And you could also, if you drag the other actor in, you could destroy whoever touched it, but no, we want to destroy this pickup. And we don't need to hit compile and save every single time. It actually does it automatically sometimes. So yeah, I can just go back here and we overlap, and you see it shows the third person character, and then if I walk in, the pickup disappears. It is that easy. On a side note though, because we aren't really checking if the other actor is a player, right, we can overlap with pawns. So if we had enemies in the game, this means the enemies could also use the pickup. So that is something we're going to get into later, how we can prevent this. But for now, this is good enough. And just to give you a couple more examples of how this overlap is used, it's actually very, very useful. And you can use it to determine if a character is in front of a door to open the door. You can use it for shooters to determine if a bullet hits somebody. And you can also use it in beat 'em ups or something, have like a hitbox and check if the hitbox hits somebody. There's so many different ways that you can use it, and it is super useful. Okay, but now instead of just destroying the actor, we actually want the pickup to interact with the player and tell it how many pickups did we collect so far. And then later on, we want to make the character run faster and faster depending on how many pickups we collected. And this brings us to the next topic, which is blueprint communication. This is very important. It can be a bit confusing at first, but we'll slowly start to get you into it. Basically, this just means that one blueprint is talking to another, and now we want the pickup to talk to the player, which we have a reference to by this overlap event from the other actor, right? We know this is the player, and we want to tell it to do something. We want to create a function or method on the player, which we can then call from here. So let's go to the content drawer, content, third person, blueprints, and here we have the BP third person character. I want to rename it, so select it, hit F2, just to BP underscore player to make things easier to understand. And then double click to open it up. Now in here we see all of the logic that makes our character work, but also you can see as opposed to the BP pickup, which has the parent class of actor, the BP player has the parent class of character, which has so many more settings that we have here. It comes with the character movement component that allows the movement, but then here this blueprint is interacting with the parent classes, it is interacting with the character movement component to make things like aiming possible, to make movement possible like this. And it's actually not that much because these components take care of the most things. And we just take in the inputs and then, yeah, process them basically. But that's not what we want to do now. We want to create a new function here, right? You can see there's a move function, there's an aim function, but we want to create our own first function. And just shortly, what is a function? Well, it's a reusable block of code, or in this case, blueprint nodes designed to perform a specific task, right? So in here we have the move, for example, and it just passes the inputs to the add movement input function. And this can then be reused throughout the blueprint. Right here's the same move function that is being used just with different parameters with different values that we pass in. So let's now create our own function. So functions, click on plus, and I want to call it collect pickup. And at first, let's just do a sanity check again with a print string. So here, drag off, let go print string, and I just want to type in collected. And now this function exists, but nothing is calling it, right? So now in the BP pickup, we want to call this function. So let me get rid of the print string, just keep the destroy actor, so I have some space here, and I can drag from the other actor, and now I want to call this collect pickup, right? But it doesn't show up. And why does it not show up? Because if I hover here, you can see other actor is an actor object reference. So this could be other actors, not just the player, and Unreal Engine doesn't know about this collect pickup function because, well, it is only checking for the actor, which does not have it. We need to specifically check for the BP player because then we know this collect pickup actually exists and then we can call it. So we basically need to convert or cast this actor object reference to a BP player object reference. So I can cast to BP underscore player like this and connect it. And this gives us this as BP player node. And if I drag off here, then I can look for the collect pickup, and it is actually showing up. Call function collect pickup, just like this. And then I can connect back to destroy actor. And this function only is called if the cast was successful. You can see there's also a cast failed node. So if the other actor that we touch that begins the overlap with the sphere is not compatible with BP player, which means it's not a BP player and it's not a child of BP player, well, then just the cast failed is fired and this is not being executed. So this is actually also a way to prevent enemies from picking up this pickup because it specifically casts to the BP player. And before we talk more about the cast node, let me just show you this actually works. I can start the game and I can overlap here and you can see it shows collected on the top left. Right, I run in, it says collected. So this proves that the blueprint communication between the pickup is working. It casts to the BP player, it tells the BP player to call this collect pickup function and then execute whatever we have in here. And just to talk a bit more about the cast to node, because there's a very important note about this. If you're in the Unreal Sphere for a while, you will hear how it is bad and you should avoid it because it creates hard references. Well, there is cases where we can use it because it is very convenient, it is very easy to use. It does actually come with some dangers. And without getting too much into it, so just to quickly show you something, I want to make sure this is compiled and saved and the player is also compiled and saved. And then I can open up the content drawer, go to content, blueprints, BP pickup, right click it, and you can see the reference viewer here. And now you can see the BP pickup depends on the BP player, right? So this is what is called a hard reference. The BP pickup cannot exist without the game, without Unreal Engine knowing about the BP player. And basically what this means is that Unreal will load the BP player into memory before it then instantiates the BP pickup. And without getting too much into it, because this is quite the advanced topic, in a worst case scenario, your pickup will, through daisy chaining multiple dependencies, it might even depend on the last boss of your game or some weapon that most people won't even use, right? So it's something you have to be careful with. But for now, it's nothing to worry about too much. Just keep this in your mind for later that you can look into how interfaces work and things like that. But interfaces and soft references are quite the advanced topic. I actually cover these in my JRPG masterclass, but for now, don't worry about it too much. But while we're on the topic of my JRPG masterclass, it is a 37-hour long course teaching you how to create a 2.5D JRPG with turn-based combat inside of Unreal Engine 5. It basically distills all the knowledge that took me over 6 years to learn into a compact course, and not only will you be able to create RPGs after this, but most of the lessons you learn here will enable you to create any type of game. If that sounds interesting to you, check out the course from the link in the description. Okay, now let's go back to the BP player, and I want to now expand this collect pickup function. I don't want it to just print string. Let me get rid of this. I want it to now count up and let us keep track of the amount of pickups that we have collected. So what we need now is we need some way to store a number that we can count up and up and up, go +1, +1, +1 every single time. And this means we have to get into the topic of variables. So here click on plus to create a new variable, and we can give it a name. I want to call it collected amount. And in simple terms, a variable is just a named space in memory where we can store a value. And you can think of it like a box with a name on it for which we can update the value as we please. And every place in our game that looks at that box will always see the up-to-date value. And now next to the collected amount name, you can see this red icon that says Boolean. And this is the data type of the variable. We can click on it to see all of the available types here, and on the top we have the kind of standard ones like boolean, byte, integer, float, name, string, text, and so on. And down here we have the more advanced ones like structures that Unreal Engine comes with, structures that we created, interfaces, objects, enums, and things like this. And this can feel quite overwhelming and confusing to a beginner. So just on a quick side note, there are programming languages which are strictly typed, which means we need to specify the data type of each variable beforehand. And C++, which Unreal Engine is based on, for example, is a strictly typed language, and therefore blueprints are also strictly typed. This means that we need to think ahead a little bit, but since the type can't change during runtime, it prevents us from making stupid mistakes like changing a number into text later. Other languages like JavaScript, for example, are dynamically typed, which means it automatically determines the type, and it can even change during runtime, but it comes with a whole bunch of issues and possible bugs. Okay, but now what we want is simply an integer, right? We want a whole number that goes from 0 to 1 to 2 to 3 and so on. So that is an integer. We can then compile it, and you see on the right side, if we have it selected, we can see the default value, which is the collected amount of 0, and yes, we want to start on 0. Okay, let's now start counting. So I first want to get the current amount, so I can drag this out and click on get collected amount, and I want to plus it. So add, I can just look for the plus icon here or look for add, but operators add is the one that we want to look for. Both works. And I want to just add 1. So +1, collected amount +1 is what we then want to save. So then we drag out the collected amount again and set the collected amount like this. So the result is the current collected amount +1 is the new collected amount. We then want to print string this to see the new number. So print string like this, and then connect the collected amount here. And it's going to convert it from an integer to a string to be able to show it on the screen. Let's now start this, and I can run in here, and you see it says 1. But we want a few more pickups to actually be able to see how this works. So you can open up the content drawer, and here we have the pickup. I can just drag it out again, like this. But that's not the only way. We can also just select one of these, hold Alt, and then drag here to also create a new instance of them. And let's just have these 3 here. I can walk in here, we see 1, 2, 3. This is working quite nicely. But now we want to have even more pickups, maybe like 50, and we don't want to place them by hand in the level because we also want to have some randomization to have them appear randomly within a certain limit. So this is the perfect opportunity to create a very simple spawn system where you can specify with a variable how many balls it should spawn, and I can then also show you what the begin play event is used for in a real scenario. So for now, let's just delete these pickups, select them, and hit delete on the keyboard because we're going to spawn all of them from our pickup spawner now. So let's create our second blueprint in the content drawer, content blueprints, right click, blueprint class, and again, there's nothing which is close to a spawner. We just create our own logic from the actor, which is the simplest one. And I'm just going to call bp underscore pickup spawner. Double click to open it up. And yeah, what we want to do here is we basically want to have a box collision. And you can see here's already a box, for example, that just came with a level, a post-process volume. Well, we want to have a box collision that we can just kind of drag over the level to then specify which area these pickups can spawn in. So inside of the pickup spawner, I can look for add and look for box collision like this. And you can see we have this nice box here now. And I just want to give it a name to make it more clear what is happening here. I'll just call it spawn area. And while this is selected, we have the box extent here. We could also make it bigger or smaller with the scale, but I prefer to use the box extend. I can just left click here and drag, and you can see we make it bigger and smaller on the different axes. So for now, let me just say maybe 100, 100, and then here it shouldn't be as tall, so maybe 10. And yeah, now we have this nice kind of flat box. But of course, it's very hard to specify it here. We kind of want to see it in the level and then make changes there, which we can. So in the level, we can drag out the pickup spawner, and the box is very small, but I just want to roughly place it here in the middle. And then I want to drag it in the air because I want them to kind of spawn in the air. And now we want to make it bigger to kind of expand throughout the level here. And to do that, I can select it, and then here we have the spawn area, and I can change it just for this one instance, right? So if we drag another one into the world, it's going to keep this box extend, and only this one instance is going to use whatever we set here. So for the spawn area, here the box extend, I can drag here, and we can now see in the world how does it change. So that makes it very easy to set up. And this doesn't have to be perfect. We just want to roughly match it. So maybe, let's say 1500, 1500 for the Y as well, like this. So we basically match this form. And yeah, the height is fine with 10. Actually, let's go maybe 30 to make it a little bit bigger. And yeah, so now this is the area where we want to spawn our pickups. Okay, let's now go back to the pickup spawner, and we want to create a function for actually spawning the pickups. So here, functions, create a new one, and I'm just going to call it spawn pickups. And then here we can drag off, and we can look for spawn actor from class is what should show up here. And this is a very important function that we're going to use all the time. And here we can specify what is the class that we want to spawn. Well, we want to spawn our BP pickup. So here we just click and we can search for BP underscore pickup. And yeah, so here, not the pickup spawner, very important, the BP pickup is what we want to spawn here. And you can use this to spawn enemies, to spawn weapons, and all those kind of things. And outside of the class, there are three different things that we have to specify. Let's start with the spawn transform, right? So this is the location, rotation, and scale where we want to spawn it. But we actually just care about the location. So I can right click, I can split struct pin, and now we have these default values of 0. So rotation, we can leave it at 0. Transform, we can leave it at 1. We just want to give it a location. And like I said, later we want to use a location inside of this box, but for now, let's just spawn it in the middle here and go step by step. So how do we get the middle of this pickup spawner? Well, I can just drag off here and get actor location, and this gives me exactly the middle of this actor where it is placed in the world. Then next up, we have the collision handling override, because what can happen is, for example, if we try to spawn something inside of a wall or inside of a different player and things like this, it might not be able to spawn if these things are blocking each other. And we can just kind of set what happens in that case. And I want these pickups to always spawn even if they're being blocked, so we can either always spawn ignore collision, or we can try to adjust location but always spawn. And in this case, I want to go to try to adjust location but always spawn. So if two pickups are spawning inside one another, it's going to try to just kind of slightly offset it. And the instigator, we don't really care about in this case. Okay, and for now, all this function does, it spawns a single pickup in the middle of this blueprint, right? But the function isn't being called anywhere yet, right? So even if I start the game, there's no pickup being spawned because, well, we need to call this function. And when do we want to call this function to spawn the pickups? Well, when the game begins, right? So on event graph, we have the event begin play. This is very important. And if I hover, you can see event when play begins for this actor. And the for this actor part is very important. Because the pickup spawner is placed in the world, well, the game basically begins the moment that I hit this play button. But we might have a situation where we spawn enemies later, where we spawn pickups later. For them, the begin play happens once they're spawned into the world. And this could be later throughout your game, right? But now for the pickup spawner, all we want to do is on begin play, we want to call this spawn pickup function. So we can just drag it out and then we connect it here. Let's now start the game. And you can see the pickup, it spawns in the middle and it falls on my head basically. And if we want to see it more clearly, I can zoom out, and instead of pressing play here, I can simulate, right? So you simulate the level and we can see how it spawns and how it falls down. Now this way our player doesn't spawn, right? We just see whatever is happening here, and this is fine. And let's go back to the pickup spawner, right? So begin play is very, very important. You're going to use it all the time. And for example, you can use it to apply stats depending on what level your character is, to set the health, the mana, and so on. And you can also use it to maybe load up the default amount of ammo into a gun, and so on. There's so many things where you can use it. Okay, but now before we go into spawning multiple pickups, let's go back to the spawn pickup function. Well, first we just want to get a random location in this box instead of using the get actor location. So let me delete this. And there is a very nice function that Unreal Engine gives us that we can use. So I want to drag this over a little bit. And I want to drag off from the spawn transform location, just drag out here, and then look for random point in bounding box, this one. And this is exactly what we're looking for. And just on a side note, if I have two nodes selected and hit Q, it lines them up nicely. Okay, so where is the center? Well, the center is either the center of this actor, which we use the get actor location, but to make it more clear, I want to get the spawn area and not get the actor location, but get world location. So transformation, get world location in here. And this just makes it clearer in case that maybe the box is not in the middle of this blueprint, right? We want to get off the box, so that is just a better way of doing it. And then for the half size from the spawn area, we can drag off and we can get scaled box extend like this. And all of these things are just nice helper functions that Unreal Engine gives us, right? Otherwise, we would have to calculate this ourselves by just looking at the box, how big is the box and things like this. But no, Unreal Engine has this for us already prepared. So it's basically like a function library. Okay, let's now go back here and I want to use the simulate again. And you can see if I exit out and spawn again, escape, spawn again, it always spawns in a different location within the bounds that we have specified here. So this is exactly what we're looking for. But of course, now we don't just want to spawn a single pickup. We want to spawn 50, 100, whatever. We want to be able to just give it an arbitrary number and repeat the process over and over again. And repeating things like this is what a computer is very, very good at. So let's go back to the pickup spawner. And I want to open up even more space here because on the left side, we're now going to add something that is called a for loop. So let me just drag off here and look for loop. And we don't want to use a for each loop. This is if we use an array. We're not going to get into this time. But flow control for loop is what we're actually looking for. Now what happens here is it's going to activate this loop. And we can specify the start amount and the end amount. So to be precise, this is actually a range-based for loop. And it's just going to repeat the process as many times as we set the indexes here. And it's going to do everything on the right side again and again and again until it is done. And then it just completes. So for now, we want to spawn 50 pickups. So we start at 0. This means we don't want the last index to be 50, but actually 49, because the 0th turn also activates. So then this 1 plus 49 means 50. And again, if you're new to programming, this might be confusing, but you're going to get used to it. So let's go back to the map. I hit this simulate again, and you can see we get these 50 pickups spawning here. And every time the location is random within the area that we have specified. Let's now go back and make it a bit more readable because again, like this is quite confusing. I want to be able to just set a variable with the number that we want to spawn. So let's start at 1, not 10, at 1 to 50, right? So now we get 50, but it's more readable. It makes more sense to a regular human being. But still, just having the 50 here is what we call a magic number because it doesn't really make it clear what our intention is here. So I can just drag off and I want to promote it to a variable, not a local variable, promote the variable. And I just want to call it spawn amount. And just reading this makes a lot more sense to everybody else that looks at your code or your nodes. And what I just used here is a shortcut because last time, on the player, I clicked here on variables and we had to type in the name, we had to put in the amount. Here, I just dragged off and I used this shortcut promote to variable. And this already gives us the correct type of integer. And if I compile, it already gives us the default value that we had in here before. So I prefer to use this. There used to be some bugs with this in earlier Unreal versions, but now they are fixed. And the great thing is if we now want to change the amount to spawn, I can just click here and instead of 50, I just type in 30. I go back into the game, I can start, right? And now we only have 30. But it's a little bit annoying to go back in here and go out again, go back and go out again. So there's actually a cool way how we can just do this in the level right away. So on the pickup spawner, I can select the spawn amount and I can make it instance editable like this and compile and save. This time we actually do have to compile and save. And now if I go back to the level and I select the pickup spawner, you can see now the default spawn amount is out here in the world. So this makes it very easy for you if you're in game designer mode, level designer mode, or if you're working with a game or level designer. They don't have to go into your blueprints. They don't have to understand what is happening here. They basically just have a couple of exposed variables here. I can just set this back to, let's say, 100. and I can start it, right, I can very easily just test whatever is happening here without having to understand the blueprint logic. But actually, let me just go back to 30 on this. 30 is the value we want to work with. And yeah, this just makes it a lot easier. And this also means, just as an example, if I duplicate this, I can hold Alt and drag it out. I can have 30 on this one, and maybe on this one I have 100. So this is changed on a per instance basis, right? We don't have to change it in the pickup spawner. This is very useful if you have maybe kind of trampolines or platforms that should behave differently. You don't have to make a different blueprint for each of them. You just kind of expose the variables, the parameters that you want to change. Okay, but let me now delete this one on the right side, the pickup spawner 2. Just hit delete. We just want to keep this one with the 30. Let's now just start the game regularly, and we have our character. We can pick up these spheres, and you can see the counter is going up, right? So this is basically like our score. This is already a simple game technically, but it is quite boring because nothing changes. We always just do the same thing, and it is quite slow. So what we want to do now is we want to make every pickup make us slightly faster. So let's back out here, and on the BP player, we want to create a function that makes us faster after we collected a pickup. So let me create a new function here and just call it increase speed, like this. And before I worry about the implementation, let's just go back to the collect pickup. And then after we print it, let me also just call this increase speed, right? So we can call one function we created inside of a different function that we created. And let me go back to the increase speed. So how do we actually affect the speed of the character? Well, here we need to somehow understand the character movement component a little bit better, because this is basically what takes care of all of the movement of our character. And there's so many different parameters on here, right? We have gravity scale, max acceleration, braking friction, right? There's so much in here that we can edit. And well, it's going to take you a bit of trial and error to figure out what we actually want to change here, but I already know it. So we can just look for max walk speed, which is what we actually want to change. So this is 600 centimeters per second. And I could just directly change it here to make the character faster, but I want to do it, of course, through Blueprint visual scripting. So how do I do this? Well, I can just drag the character movement component out here, and I can look for the get max walk speed here to get the current value, and I want to add to it. And this is very similar to what we did on the collect pickup, right? We get the value, we add something to it, and then we set the value. This is a very common pattern that you're going to use all the time. So we want to plus, I look for the plus icon, operators add, and let's just start with 25 maybe, 25 units. So it's 600, then it's 625, 650, 675, and so on. And then I have to set it. So I could just drag from here and set it, but I just want to copy paste this, Control C, Control V to keep it cleaner, and then set max walk speed here, and then connect it up here like this. And then I want to give it the value, and I want to double click here just to have a reroute node and make it look a little bit cleaner. And just select this and hold Control, select this, hit Q to line them up. Let's now try this out. I go to the game, I start it, and it's not going to be obvious right away, but the more we pick up, the faster we get, right? So now I think you can start to feel it. We're probably like 800 now, something like this. And yeah, this alone makes the game a little bit more exciting, right? Because there's some change, something is going on, and yeah, we become faster and faster. Okay, but now back in the BP player, I don't want to have this magic number again. I just want to drag off here again and promote to variable and call it speed increase per pickup, which is kind of mouthy, but it very much makes it clear what is happening here. And just on a side note, why is this so easy in Unreal Engine while it is so hard in many other game engines? Because, well, Unreal Engine gives us this actor component, right? The character movement component. It has over 10,000 lines of code. I looked at it. It is so hard to understand, right? But this is what most Unreal Engine games you play are actually using. They're not making their systems from scratch, and they're just kind of interacting with it in this way that we're doing right now. Of course, you could make your entire movement system from scratch, but in our case, this fits our needs. And also, you could make your own actor components. Just an example, I could right click, blueprint classes, and here we have our own actor component. We can make reusable components that we can add, like maybe a health system you could make in a component. It is a self contained system, and you could then just attach this to different characters. Again, that is a bit advanced, but keep that in mind. It is a very nice way to keep your projects clean. Okay, but just kind of running around here and getting faster, while it is more exciting than before, we kind of want to have an enemy that chases us to make the game even more exciting. And this will be a chance for me to show you how the tick event works. Open up the content drawer, go to the blueprints folder, right click, and make a blueprint class for our chaser enemy. And basically what I want this to be is to just have a cone that tries to keep on following the character. And here we also don't want to make the movement from scratch. So this time actually we don't pick the actor. We want to pick the character because it comes with the character movement component, making things so much easier for us. And I will call it BP underscore chaser and double click to open it up. And you can see now here we have the character movement component, we have the arrow, we have the mesh, we have the capsule component. There's a lot of things this gives us as opposed to just going from the actor, for example. Now we're not going to use the skeletal mesh, I'm just going to ignore this. We instead want to add a cone. So I want to go to the top, the capsule component, and just add a cone like this, basic shapes cone, and we can just leave the name as it is, that is fine. But I want it to point in the same direction as this arrow because that is the forward vector of the character. And there's multiple ways I can do this. I just want to switch to rotate mode, and then here I can drag on the green to be minus 90 degrees, 2-point forward. And I also want to move it forward a little bit, so I can use this translate object and just move it forward slightly, so it's going to be kind of in the middle here. So just 10 forward. And now I'll make the capsule a bit smaller to match this roughly. It doesn't have to be perfect, of course, but the half height, maybe I can go down to like, yeah, 50 or something like this. Yeah, let me just go with 40 and then also 40 on the radius, right? And this is enough. This is good enough. It doesn't have to be perfect. We actually want the visuals to be a bit bigger than the actual collision. And we don't want to use the collision on the cone. So let me go to the cone, scroll down to collision, and here it says block all dynamic. We don't want this. We just want to have the capsule overlap with the player. So on the cone, just set this to no collision because it would lead to issues. And then on the capsule component, I want to go up here again to collision, open it up, open up the collision preset, and I want to set this to custom again. We can block everything here. Actually, the camera I want to ignore again so that the camera doesn't zoom in if this is in front of the camera. And also for the pawn, I want to only overlap. So this is basically a similar setup to what we have on the BP pickup. So we could make a reusable object type, a reusable setting, but that is quite advanced. We just do it here with the custom. And also very important, the generate overlap events is checked. Otherwise, this would not work. Okay, now what do we want to do in terms of logic? Well, I can go to the event graph, and the first thing we need, well, we need to know who to chase, right? So we need to have a reference to the player, which we save here in a variable, so that we always kind of start to move towards the player. We always know where the player is, and we try to move towards the player. And an easy way to do this is to right-click here and get player pawn. Again, this is a built-in function of Unreal Engine that is related to the gameplay framework, right? So this allows us to get the pawn, which in our case is the BP player, once the game starts. And then I just want to save a reference to that in a variable, so I can drag off here and promote to variable, and I want to call it target player. And it is of the type pawn you can see here, right? So this is an advanced type inside of the object types here, and I want to connect the begin play here. Now, with things like this, you have to sometimes be careful because does the pawn even exist in the world before the chaser is spawned? And yes, because Unreal Engine actually spawns the player for us, we know it exists before the chaser. But if you just use some other arbitrary blueprint, you have to be a bit careful with doing things on begin play like this, getting references and stuff. Okay, and what do we want to do then? Well, we want the chaser to always move towards the player on every frame the game is running. So let me just delete this begin overlap and talk about the tick event a little bit. So just to show you, I can drag off here and print string, and let me just say tick. And I can start the game now. Well, first I have to drag the chaser into the world because now it doesn't exist, nothing is happening. Let me just drag the chaser in here, maybe on top of here, it doesn't really matter. And if I start the game now, you can see tick. It says tick on every frame the game is running. And how many frames is the game running at? Well, I can stop the game, click on this eye icon here, viewport stats, and show the FPS here. And if I start the game now, you can see, in my case, it is unlocked, it's running at 80 FPS. It depends on what your computer is set at. Maybe it runs at 60 FPS locked for you, which is probably the case for most of you. So this means this is firing off 60 times per second. And maybe if you have a high frame rate game, 120 times per second or so on. So it is actually quite dangerous if you do the wrong things. If you do heavy operations here on tick, it can really slow down your game. It can lower the FPS of your game. So it is something you have to be careful with, but don't avoid it altogether like many people are saying. And what we're doing right now, it actually requires tick to work because we always need to know the new position of the player, and on every frame we want to move forward. So this is a perfect use case of tick because there's no like event-based way of doing this. So the rule of thumb is if you can do it without tick, do it without tick, but for things like this that constantly need to be updated, use tick. Okay, let me get rid of this print string, and it's actually very easy to set up. I just want to drag here and set actor rotation like this, because first we just always want to look at the player and then later we worry about moving forward. And here for the new rotation, Unreal also again gives us a very nice helper function. It's just called find look at rotation like this. And we want to give it the start. Well, the start is this BP chaser, right? So get actor location is the start point. And what do we want to look at? Well, we want to look at the player, right? So I can get this reference to the target player from here. This is where we save the target player in the variable. So I can get target player. And here I can get actor location like this, and then connect it to the target. Okay, now let's go back to the game and start it. And where's the chaser? It's over there, right? But as I'm moving around, you can see the cone is always pointing at me, right? So every frame of the game, the cone is checking where the player is and it is updating. And you can see we still have the same FPS of around 80, right? So this is a very, very simple operation. This is nothing you have to be careful with, nothing you have to be afraid of. Okay, but next I want this chaser to float in the air. I don't want it to just kind of be stuck here. It should be a kind of like an airplane that can fly, and it should always move forward in the direction that it is pointing on every frame of the game. So the first thing I want to do is I want to go to the BP chaser, I want to go to the character movement component, and here we can change the default land movement mode. And we don't want to be walking, we want to be flying. And that changes how gravity works, that changes how fast we are, and things like this, right? But this is a big change. But what it does, if I start the game now, and let me just do the simulate mode, the character doesn't fall down, it just floats in the air, and it can actually move in the air like an airplane, like a helicopter, and things like that. But now I also want to add movement to it, right? And how do I make it move forward? Well, after the tick, I can go here, I can right click and look for add movement input, this one, and you can see target is pawn. So this comes from our parent class, not the character. Even one level higher, the pawn gives us this function, and I can drag it here. And scale 1.0 just means it goes forward with full force, that is fine, but I have to give it the world direction. So which direction do I want to move in? Well, very easy. I can just drag off and get actor forward vector, right? So by applying the rotation, we change the forward vector, and then in the next step, we use it to just tell it to move in that direction. And just on a side note, because now we are in the flying mode in the character movement component, we don't use the max walk speed, right? We use the max, I think, fly speed. Yeah, max fly speed is what it's using now. And I just want to try it out with 600. Let's see what this feels like. I want to start the game, and you can see it is coming towards us, right? So this alone makes the game much more exciting. We have this thing chasing us, but of course, even if it touches us now, it doesn't really stop the game yet. So that's what you want to do. Like if it touches us, we want to restart the game. We lost. And this is kind of similar to what we did on the BP pickup, right? We have the on component begin overlap, we detect the player, and then we collect something. Well, in this case, it is slightly different, but it is the same principle. So on the BP chaser, I want to go to the capsule component, right click, and we go to the add event on component begin overlap. We know we can only overlap with pawns, but we again want to specifically check, are we overlapping with the player? This time, we don't need to call a function on the player. We don't need to call collect pickup or anything. We just want to know if it is a player or not. And we can actually, of course, we could just cast to BP player again, but that would create a hard reference. Like I said, in this case, we don't need it. There is a slightly better way. So instead, I want to check for is a and is a soft reference, right? So we just use a soft reference. It doesn't create this kind of dependency that I was talking about before. And we just check for soft class is BP player. And this is actually a new node that we got with Unreal Engine 5.5. And all we do here is we basically check, is the other actor a player? If it is, then I want to restart the game. So I can drag off here and just open level by name like this. And I have to give it the level name. And I just want to restart in the same level. So I could manually type in level third person. But what if we change the name? It doesn't work anymore. So actually, I just want to drag off here again and get current level name like this. and then just drag this in here, and it's going to convert from a string to text, nothing to worry about. Okay, now let me start this, and if the chaser touches me, the game is just going to reset, and we lost, basically. So now we have a lose condition, just making it a more full-fledged and proper game. But we still don't have a win condition, right? So to turn this into a full game, we want to have a way to win the game. We already have a way to lose it, but now let's implement the kind of goal of the game. And I basically want to create an elevator that activates if we have all of the pickups collected, and then it brings us up to the goal platform where the game then ends. And why do we want to make an elevator? Well, I want to show you how timelines work because they are also very, very useful. So let's now start with the elevator. Go to the content drawer in the blueprints folder, right click, make a new blueprint class. And again, this is something simple, so just the actor, and call it BP underscore elevator. Double click to open it up. And first, I want to give it the platform that the player can stand on. So add, and I think cube is the best for this. And we don't have to rename it, cube is fine, but we need to change it to be more of an elevator platform. So here I want to unlock this so we can change the values independently. And let's say 5 on the X, 5 on the Y. And I don't want it to be as thick, so maybe just go with 0.5 on the Z axis like this. And yeah, this is just a nice platform. And now let me just go into the level and place it, let's say, on the opposite platform of the chaser. Here's the chaser, and here I want the elevator to be. And I can just drag it in here into the corner like this, so it doesn't overlap with the wall, just like this. And then also make it come out of the ground like this, so a little bit slightly that it is above the ground. Okay, and now I want to specify how far up does the elevator go. So where is the top position and where is the bottom position? So let me go back to the BP elevator and let me just save everything once because you can see all these stars, like nothing is saved. Control Shift S, or you can also go to File and Save All, just to make sure in case something crashes, you don't have to redo everything. Okay, now let me specify the top location, right? So for example, here, this I want to be the top. And the best thing to use here is a scene component. So I can go to this one, click on this one, make sure to not be on the cube, then click on add, and we can look for scene, and we have this utility scene component, and you can see it has a scene transform and can be attached to other scene components. It's the most simple thing we can have here. And I want to call it top lock for top location, and then in here I can just drag it up, and you can see 10 meters, whatever, 5 meters. And yeah, it doesn't really matter here. I just go with, let's say, 700 for now here. But the problem is, like, if I click away, we can't really see where it is. So there's a nice little trick we can use while we have the top location selected. Go to add and look for billboard like this. And the position is messed up right now. So here I just want to reset it. And now even if I click away, we can see this kind of dragon icon here. And it just is a nice way to kind of show where the scene component is. And if you wanted to, you could change this icon to be something different, right? But this is good enough. And now I also want to have a bottom location. So let me just select this, hold Shift, and then click the billboard here, Control C, click on the top, Control V, and now we have this scene here. I want to rename this, so F2, and call it bottom lock. And we have the billboard attached here, that is fine. I just want to reset it here. So click on here to reset it so it is in the cube at the bottom here. And then we have the top location up here. And these are basically the two locations that we kind of move between. And we can also see them in the game now, right? You can see this here, and we could change this on an instance basis. Maybe you have an elevator that goes higher, one that goes lower. You could just change it here, right? The top location, move it up and down on a per instance basis. But let us now implement the movement. So on the BP elevator, let's go to the event graph here. And there's multiple ways that we can smoothly move the platform, the cube, up and down. We could use the tick event again, like we did for the chaser, and do our kind of custom calculations and just move it up and up and up, or down and down and down. But there's actually a better way using something called timelines. So I can just right click here, add timeline, and the one at the bottom here, not timeline component, just add timeline. And I just want to call it move. And this might look a bit intimidating because there's so many different inputs and outputs, but it's actually not that hard to understand. You can think of it like a mini tick that we can activate and that we can stop. It just by default just runs one single time. It always updates on tick here and executes whatever we want. And then once it's done, it just finishes. So for things that you don't want to happen all the time, this is perfect. But what do we want to do on update on tick? Well, we want to grab this cube and then we want to set world location of the cube like this. and just connect from update, right? So this allows us to smoothly update the world location of the cube. But how do we calculate this new location, right? So this will always update and it will always be something between the top location and the bottom location. So based on how much time passed, it might be here, it might be here, it might be here, but it will always be between these 2 points. So back on the event graph, there's again a nice thing that Unreal Engine gives us, and I can drag from the new location and I can lerp vector, this one. So it's a linear interpolation between A and B based on the alpha. So this means if the alpha is 0, it just gives us A. If the alpha is 1, it just gives us B. And if the alpha is 0.5, it gives us the middle point. So always something in between if it is between 0 and 1. And this is exactly what we're looking for. So let me open up some more space here and let's first define the A and B before we get into the alpha. So A is the starting position, so that is bottom location. And I just want to get world location here, and plug it into the A. And then for B, I want to get the top location and also get world location here and plug it into the B. Okay, so now we have our A and B, but how do we move between these? Right? Because now it would always just give us the A because it is always 0. The alpha is always 0. So we now need a way to change the alpha over time, and that is where our timeline comes in. Right now there is no alpha, there's no like float output, but we want to have a float now that we can plug in here. So let me double click here and we can create tracks here. So let me create one track first and add a float track, right? Because a float is what we're looking for. And I just want to call it alpha to make it very clear what we're doing here. And how long should it take for the elevator to go all the way up? And let me just guess, I think like maybe 2.5 seconds for one interval of the elevator. So let me put in 2.5 and then I can zoom out here with the middle mouse wheel. And again, right click, I can kind of move around. And I now want to set a starting point, right? So a curve, we can create a curve here and an end point. And I want to start at 0. So right click, add key to curve float. And the time is 0. We start at 0 seconds and we start with the value of 0, right? And let me just go back to the event graph, right? We want to start with the 0 because we want to start at A. And then over time, we want the alpha to change to 1. So let me go back here and then right click again, add key. And these 2.5 seconds is what we want to take. So time is 2.5 seconds. After 2.5 seconds, we want the value of 1, right? Like this. And this is basically the movement of our elevator going up and up and up as time moves on. So let's go back to the event graph. And now I want to connect this alpha to this alpha here. And let me just move this up a bit, double click to create the reroute nodes here, just to make it look nice. And then I can just go to the left a little bit here. Okay, but now we also need to start this, right? Because this move is never being called. I want to create an event here, not a function. I just want to right click, custom event, add custom event, and that basically allows us to create our own kind of versions of these events that we can fire off, but we can just call them just like a function. There isn't that much of a difference. But let me rename it F2 start elevator, like this. And first, we want to play from start. And this is very important, not play from start. This just allows us to reset it to the start state of this curve, right? Because if it's play, it might start in the middle wherever you are currently, but no, we want to play from start from the beginning. And when do we want to start the elevator? Well, later we want to start it once all the pickups were collected, but for now, I just want to, for testing, start it from begin play. So here, I can just look for start elevator, and it's going to call the function or the event of start elevator, and then the movement is going to one time go from the bottom location to the top location. So let me try this out, and I just want to use this here, the simulate, and you can see we are moving up one time and then it stops, right? So this brings us closer, but we want to go up and down and up and down and up and down all the time. So let's work on this first. How do we do this? Well, back in the elevator. Well, once it is finished, we just wanted to start again, but actually we wanted to reverse. And we can't just go from finish to reverse. This is not allowed. But there's a very cool thing we can do, and I just want to open up some space here. We can use a flip flop. So on the start elevator, I want to flip flop like this. And it basically means the first time it does A, the second time B, then A again, B again, A again, B again. So for B, I just want to reverse from end. So I want to play from start or reverse from end. But I then still need to call this after finished. So after finished, I can just call the start elevator again, like this. And this way we basically just call this indefinitely, right? Like once it starts, it's gonna go up and down and up and down and up and down. So let me just show you, simulate, and it goes up. After 2.5 seconds, it goes down. 2.5 seconds, it goes up. Now the movement here feels a little bit robotic. It might be hard to get on the platform. So I wanna implement some easing in and easing out here. So back in the BP elevator, this is actually very easy to achieve. Double click the move. And here I just want to select these curves, these points. So just like this, left click, and then right click one of them, and we can use auto. And you can see now it kind of smoothly goes here, and then it kind of smoothes down here. And let me just show you again. Now it kind of gets faster, it slows down, faster, slows down. And yeah, this just makes it easier to get on the platform for the player. It just looks better. Now, one thing that is a problem, some of the balls might spawn on top of the platform, and well, we want to activate the platform after we collected all of the pickups. So this is a bit of a problem because this could soft lock our game basically. So I just want to make this spawn area a little bit smaller. So if you can't click it, maybe look for the pickup spawner here in the outliner. And let me just click on the spawn area and make it 1300 and 1300, just so we cannot spawn anything on top of this platform and soft lock our game basically. Okay, now the next step we want to do is we don't want the elevator to start right away. We only want it to activate after we collected 30 pickups. So on the elevator, let me go to the event graph and just delete this start elevator event. We will have to call this after we detected that all of the 30 pickups have been picked up. Now here things get a little bit advanced, but where do we know after a pickup was collected? Well, on the BP player, right, we have this collect pickup function that fires off every single time that we collected a pickup. So what we can do here is we can use an event dispatcher, which basically just broadcasts a message outside is like, hey, I collected a pickup. And then everybody else, like the elevator, can listen to that event and be like, hey, this guy collected 30 pickups. Let me start the elevator. So while it might sound a bit intimidating, it's actually quite easy to use. So let me create an event dispatcher here, and I just want to call it collected. And then here on the right side, I need to compile and save, and I want to drag it out. And what do we want to do? Well, we want to call that we collected, right? So after we collected, after we increase the speed, we just send out the message, hey, I just collected. But that is not enough. We want to tell it also how many did we collect, because I need to listen to these 30 collected, right? So I can click again on the collected. We have the inputs here. I can click on plus, and then here, I just want to give the amount, and it should be an integer to match this collected amount integer here, right? And then I can just drag this out here, get collected amount, and pass it in here and pass the data along with the message that we're broadcasting. Right, but now we are broadcasting the message, but nobody's listening to it. So we have to go back to the BP elevator and we need to bind to this event dispatcher. So on begin play, we're again going to look for the player. So right click, get player pawn, like this. And here we have to cast again. So cast to BP player, because we need access to this event dispatcher, like this. Right, so this elevator now has a hard reference to the player, which is not ideal, but again, the player always exists in our game. This also isn't a big issue. But then I can bind to bind event collected. And yeah, here, so bind event to collected is what we're looking for. And whenever this happens, then this event is being fired off. So let me drag off here and custom event, add custom event. And it is customary to just call it on. So on, and then whatever this is called, so on collected, like this. It then gives us the event and it gives us the amount, which is great. Now, what we want to do is we want to listen for the amount and we want to check if it is greater or equals, right? And you can use these here, or you can just try, or you can just type greater equal as well and use this one. And what you want to check? Well, greater equal than 30. And then here we create a branch, which is basically an if-else statement if you're familiar with programming, right? So this is if and this is else. So if we have collected more than 30, then true, then we want to start the elevator, right? So true, start elevator like this. Right now, this with the bigger equals than 30 here is not ideal, right? Because we have multiple sources of truth. We have this 30 here. If we select the spawn, the spawner, then this is the spawn amount of 30. But if I change this amount, well, I have to go into the elevator and change this as well. Now there's ways around this by using global variables or by specifying the amount in the game mode, right? But that is a big side tangent I'm not going to get into. So for now, we just remember if we change this value, we also have to change this value. And for now, that is good enough. And let me now show you that this works. I'm not going to have you watch me collect all 30, so I'm going to fast forward. But now I just have these two left, and you can see the elevator activates once I collected all 30. And now I can just get on the elevator, but it is actually quite hard with the chaser behind me. So I have to time it and get on the elevator, and it is working. Great, but now we actually want to create the goal, a platform with a goal that the elevator takes us to. So open up the content drawer, back in our blueprints folder, right click, create a new blueprint class, and it should be an actor, and it's called BP underscore goal, and double click. And well, we need a platform again. We can actually just go to the elevator. Let me see the viewport. This cube, I can control C, I can go to the BP goal and control V, and now we have the cube with the same dimensions here. And now I want to have a box collision similar to the pickup where you have the sphere. I just want to check with a box collision if the player walks in here, and then we know we want the goal to trigger. So add box collision, collision like this. And I just called goal trigger to make it very clear what is happening here. And I need to make it bigger. So let me drag it up first like this. So it's on top. And then the box extent, I can make it bigger. Let's say, yeah, 220 like this and 220 like this. And then, yeah, 32 there is fine. So if the player enters here, then the goal should trigger. So to make that happen, I can, again, right-click the goal trigger, add event, on component, begin overlap. Well, but first I need to check the collision settings. So again, goal trigger, I want to go down here and collision settings, instead of overlap all dynamic, I just want to set this to custom again. By default, I want to ignore everything. So just click here, ignore everything. And just for the pawn, we want to check for the overlap. And again, generate overlap events should be active. And now again, I don't need to call a function on the player. We can actually do the same thing that we did for the chaser, right? Where we just check for is a soft. And I can just copy paste this control C, go to the goal, control V, or I can just look for it again and connect the other actor to the object and check for the BP player here. And for the goal, very important, we want the goal to only trigger a single time, right? We don't want to walk in the goal, out the goal, in the goal, out the goal, and trigger it multiple times. So I just want to use a do once here, not the multi-input, just the do once. And yeah, this just means the second time we call this, it's just not going to do anything. It's just going to stop the execution here. And then first, I just want to print text this time, not print string, print text. And I want to format text. And this just makes it easier to kind of print out more complex messages. And I just want to show the player how long did they take to beat the level. So I just want to say, you beat the game in colon, and then I can have these curly brackets here, time. And if I hit enter, you can see we get this input for the time here. So how do we know the time? Again, Unreal gives us a nice function. I can just right click, get time seconds, and this gives us the time it took since we started the game. So here I can just connect it, and then we're just going to tell the player, hey, you beat the game in X amount of seconds. And then I just want to restart the game again after 2 seconds. So let me have a delay here. So delay of 2 seconds, and then I just want to restart the game again. So I can use the same in the BP chaser. We have the get current level, open level, control C, in the BP goal, control V, bring this in here. And yeah, so we tell the player a message, then after 2 seconds, we just restart the game. Okay, let's now place the goal. For now, just for testing, I just want to place it on the ground. So BP goal, just place it on the ground, start the game, and I can see, where is it here? I walk in, it says you beat the game in 2 seconds, and then after 2 seconds, it just restarts, right? So this alone gives us a kind of incentive. It gives us a kind of high score so you can play with your friends and see who is better. But let me now place it in the correct position, and it should just be here. Let me drag it up here to the left side, kind of on a similar height than this platform, right, where we have the end position, and just bring it over to the side so we can then go from this platform onto this one, and yeah, we reach the goal. But yeah, something I noticed is that the game is a little bit too hard because the chaser is very, very fast. So it makes it very hard once we're on the platform, on the elevator. So let me just adjust the speed of the chaser. So in the BP chaser, on the character movement, max fly speed, maybe go for 400 instead. And yeah, this is something you can tweak. You can have your friends playtest and they're going to tell you, hey, this is too hard. This is too easy. you can maybe, like we did with the speed of the character, make it become faster and faster over time, right? So this is where you can kind of start to apply what you learned so far. And yeah, so this is a little bit boring at first, but right, once it comes closer, we still have to be very careful. And especially once we go on the elevator, we have to be careful. And now let me collect the last one. Basically, I have this, and I now want to get on the platform here, but I want to make sure the chaser takes some time to get over. So the tactic is to just kind of have it come over here, and then I can start running over. And I want to time it. And let's see, let's see, let's see. I can get on. And then here, I can walk onto this platform, and I beat the game in 50 seconds, which I didn't show you. And now you basically have a complete game. You can now go in here, you can tweak the values, right? You can maybe change the amount of pickups, you can change the speed of the elevator, the height of the elevator, right? So you can make your own adjustments, have your friends play, and yeah, congrats, you are now a game developer. But the game itself still looks a little bit boring, so without spending too much time, I just want to go on a little bit of a side tangent on materials, and so we can have some cool glowing materials to make it look nicer within just a couple of minutes. Now go to the content drawer, content, right click, make a new folder called materials, then open it up, and let me right click again, and here we can make a new material, and I'm just going to call it m underscore glow, then double click to open it up. And while this looks a little bit like Blueprint Visual Scripting, it is actually different. It is kind of the shader graph for the materials, the material graph. And we're going to keep it very simple here. I just want to set a color and a strength for the glow and then plug it into the emissive color. So I can hold 4 on the keyboard, the 4 key, and left click to get this kind of color, the vector 4 color. And I can hold 1 on the keyboard and left click to get this simple parameter. And this will be our glow strength. So first I want to right click this and I want to convert to parameter, which is basically like creating a variable, right? We can give it a name and we can then update it on a per instance basis. So I want to call it glow color. I want to change the default value, so I can click here and let's just make it kind of this blue by default and hit OK. And then here, let me also right click this and convert to parameter and just call it glow strength. And we can then combine these two. So the color here, I can go from the RGBA and I can multiply like this, math, multiply, and connect the glow strength here. Let's say the glow strength by default, maybe it starts at 5. And then I can connect the result here to the emissive color. And you can see we now get this nice kind of glowing orb here. Make sure to apply. This might take a little bit. And then save. And I'm done with this one now. I can close it down. But I want to create instances of these. So material instances. So we can have a red version, we can have a blue version, we can have a green version. So I can right click, create material instance, and I just call it mi underscore glow red. And I can double click to open it up. And then here I can just change the glow color to be red. Everything else is the same, but let me just go kind of full red and 0 on the green and hit OK. And I can close this down. Let's make the next one. Create material instance, mi underscore glow green, and open it up. And then here again, the glow color, make it green. Let me just go full green again. Okay. Close down. And then lastly, let's make material instance mi underscore glow underscore blue and double click it. And here, I just want to change the glow color and just make it full on blue, no green here, and hit OK. And now I can close this down. And actually, I can hit Ctrl Shift S to save everything, or here, File, Save All. And I can right click, close tabs to the right. And yeah, so now I want to use these colors inside of our blueprints, right? So let's start with the chaser. And I can look for the chaser in here, or I can also just hit Ctrl and P and look for BP chaser, which I prefer, and open it up. Then here in the viewport on the cone, I can look for the materials, element 0, and here I can look for mi glow, and I want to use the red for the chaser here. And now you can see in the level it is red. Let me look for the pickups, so content, blueprints, right? We have everything here. We can use the search, it doesn't matter. Let me use the pickup, and then here, sphere. I can look for the mi underscore glow, and I want to give it the green one. Then open up the elevator viewport, zoom out here on the cube. I can give it the mi underscore glow and give it the blue one. And the same for the goal. I also want to get to the cube and give it the mi underscore glow, the blue one, like this. And now I can go back to the level. I can start the game. This already looks a lot nicer, but let me also just make the stage a little bit darker. And the way I can do this, I can look here for light, and you can see we have this directional light. If I click here, you can see it just turns it off completely, but I don't want to turn it off completely. For the intensity, let me just go for, let's say, 0.5 lux, and you can see now it is quite dark. I can start the game, and yeah, so this just kind of emphasizes the glow a little bit more. And yeah, just this small change makes the game just look a lot more interesting, and you can see even on the character, the red is kind of just shining onto our character on the reflective material. And yeah, so now you have the full game. It looks a lot nicer. Of course, there's thousands of things you could do to make the game look even better and to play even better. But yeah, so this was your first step in becoming a game developer. Congratulations. And again, if you want to learn how to make more complex games, check out my JRPG masterclass from the link in the description, which won't only teach you how to make JRPGs, but how to master Unreal Engine and blueprints in general. As always, a huge thanks to my awesome patrons and YouTube channel members.